Today's lesson is 7-3, multiplication properties of exponents. We're going to use multiplication exponents of, or properties of exponents to evaluate and simplify expressions.
Okay, the first thing I want you to do is get out your notes sheet, and we're going to go ahead and fill in our definitions and our examples before we move on and look at the examples in the PowerPoint. So the first property that you have is called the product of powers. You see that here, number 4, the product of powers. And it says that the product of two powers with the same base is the base raised to the sum of the exponents. And the wording is different on the sheet. So you're going to fill in sum of the exponents on your sheet. Sum of the exponents should be written there in those blanks now. Now let's look at what that looks like in practice. Over here you see that a to the m times a to the n equals a to the m plus n. That's what we mean by the sum of the exponents. Notice that my base is a. It's the same. That's what we're calling the base here, is my big number, my base number. In numbers, here are some examples that we need you to get down. You have 3 to the 5 times 3 to the 4 equals 3 to the 5 plus 4 equals 3 to the 9. So again, that is 3 to the 5 times 3 to the 4 equals 3 to the 5 plus 4. And that equals 3 to the 9. 3 to the 9th power. All right. Let me get a pen. I think it shows up better. Blue. Let me change to a pen real quick so I think it shows up better than pencil. The next, thank you, numbers that you're going to look at, we're going to say 9 to the negative 5 times 9 to the 8 equals 9 to the negative 5 plus 8. Sorry, I'm running out of room here. And that equals 9 to the 3rd, because negative 5 plus 8 equals 3. Now we're going to look at some examples with variables. You need to write these down as well. If I have x to the 7 times x to the 3, that equals x to the 7 plus 3. And when I add 7 plus 3, that gives me x to the 10. So x to the 10th power. I have m to the 6 times m to the negative 2. That equals m to the 6 plus negative 2, which equals m to the 4th. So that's what I get there. 9 to the 3, m to the 4, 3 to the 9th, and x to the 10th. And those are the final answers for those problems. Now let's look at the next property. I have the power of a power. The power of a power says a power raised to another power equals that base raised to the product of the exponents. So up here where sum meant add, product means to multiply. So when I have a power raised to a power, so a to the m raised to the n, that equals the product of my powers or exponents. So a to the m times n. Let's look at that in examples. Here it is in numbers. If I have 3 to the 5th raised to the 4th, that equals 3 to the 5 times 4, which equals 3 to the 20th. If I have 6 to the negative 3 raised to the negative 8, that equals 6 to the negative 3 times negative 8, which equals 6 to the 24th. In variables, if I have y to the 7 raised to the 2, that equals y to the 7 times 2, which equals y to the 14th. If I have z to the negative 6 raised to the negative 2, that equals z to the negative 6 times negative 2, which gives me z to the 12. I'm going to put a line through my z's there so you don't confuse those with 2's. Not that it really matters because we're not asking you to write this to solve this all the way out. All right, let's look at your last example for today, and then you're going to see PowerPoint examples, and we're going to work through these together. All right, we have the power of a product. This property says that a product raised to a power equals the product of each factor raised to that power. So get all of that down. It says the product of each factor raised to that power. So a product raised to a power equals the product of each factor raised to that power. Let's look at some examples. You have a times b to the m. That equals a to the m times b to the m. Notice down here it says this is not the distributive property. Do not say that you distribute the exponent. We do not say that you distribute the exponent. Some examples of this. If I have 2n raised to the third power, that equals 2 to the 3 n to the 3. I can take that one step further and say that 2 to the third power is 8, so it equals 8 n to the 3. Excuse me. Here, let's look at another one. If I have 6 times 2 to the third power, that equals 6 to the third times 2 to the third. I'm not going to simplify that one out any further. Looking at variable examples, I have x, y to the 7th. That equals x to the 7th, y to the 7th. And then my last one, m.n. to the 4th. That equals, as you may have been able to guess by now, m to the 4th, n to the 4th. All right, this is all you're going to write on this sheet of paper for the day. Make sure that you have all of this down before you move on. Go ahead and get out your notebook paper to do the rest of your examples on, and make sure that you bring this and your notebook paper with you to class tomorrow. Okay.
All right, here's our first example. Go ahead and make sure you have this written down on your notebook paper. Number 1 says 3 to the 2nd power times 3 to the 5th power. So we've learned about 3 new properties today. We're going to be using that 4th property that says if we have the same base, then we can add the exponents. So what that means is that here, the big number, the 3 here and the 3 here have to be the same in order for me to use this property. They have to have the same base. Since they do have the same base of 3, I can take those 2 powers and add them together. So we're going to say 3 to the 2 plus 5, which is 3 to the 7th power. And that's 2,187, or you can just leave it as 3 to the 7th power. And down here at the bottom it says why this property works, because if I have 3 to the 2nd power, that's 3 times 3. If I have 3 to the 5th power, that's 3 times 3 times 3 times 3 times 3, 5 times. So altogether, if you look at this, there are 7 3s, so that's 3 to the 7th power. Take a minute. You do not have to write down the blue box, but make sure you have the work written with number 1 before you move on. All right, number 2, go ahead and take a minute, write this one down. It says 3 to the 4th power raised to the 5th power. So this is a power raised to a power. So this is our 5th property, and it says that we take those two powers and we can multiply them together. So this is 3 to the 4 times 5 power. And then 4 times 5 is 20. So this is 3 to the 20th power. It says leave the answer in this form. If the answer is 4 digits or fewer, then write it. If it is 5 digits or more, leave it as an exponent.
You don't have to write what's in blue there.
And again, why it works, it says if we have 3 to the 4th raised to the 5th, then that's 5, 3 to the 4ths. And then each one of those 3 to the 4ths is 4 3s. So altogether we have 20 of them, so that is 3 to the 20th power. Take a minute, make sure you have the work up here written down. All right, number 3 says negative 5y to the 2nd power. This one's going to be our 6th property that says if we're multiplying inside parentheses to a power, then everything in those parentheses gets taken to that power. So we're going to say negative 5th to the 2nd power and y to the 2nd power. We're going to leave parentheses around this negative 5 because the negative is also in the parentheses up here, so the negative gets taken along with the 5. So negative 5 squared would be negative 5 times negative 5, which is a positive 25, and then y squared is just that, y squared. Okay, so again, it's going to show down here why the property works. You do not have to write down the y. It just says negative 5y to the 2nd power is negative 5y times negative 5y. So we can say negative 5 times negative 5 and y times y, which is 25y squared. Take a minute, make sure you have the work written down before you move on.
All right, let's look at number 4. We're going to address a couple of things here in number 4. Go ahead and get this written down. You have m to the 4th times n to the 5th 8 times m. Anytime a variable has no exponent, a variable or a number has no exponent listed with it, it's an understood exponent of 1. The property that we're looking at here is going to be property number 4, but the first thing that I want you to do is go ahead and rewrite the problem and give that last m an exponent of 1. Now the property number 4 tells us that a to the m times a to the n equals a to the m plus n. The key here is, again, that the base a is the same. So that tells us that we're only looking for variables that are the same, or numbers that have the same base. So you have m to the 4th and m to the 1st. Now n is a different base variable. So we're not addressing that right now. It's just going to stay by itself because there are no like terms or like base numbers to combine it with. So here we have m to the 4th and m to the 1st, and those are the only two that we're addressing here. The property tells us that that equals a to the m plus n, or m to the 4 plus 1. Again, our n to the 5th stays by itself. 4 plus 1 we know is 5, so that gives us m to the 5 times n to the 5. And that is our final answer there. Make sure that you have that written down. And if you want to know why this property works, look down here, and it says m to the 4 times m to the 1. Gives you m times m times m times m times m, or 5 m's, m to the 5th. You don't have to write down what's in blue. Just make sure that you have this work right here written down before you move on.
All right, number 5 says m to the negative 6 raised to the negative 3 power. So this again is a power raised to a power, so that's property number 5. And it says if we have a power raised to a power, we can take those two powers and multiply. So we're going to say m to the negative 6 times negative 3, and that's going to give us m to the positive 18. Take a minute. Sorry about that. Take a minute. Make sure you have that work written for that one before you move on.
All right, look at number 6. You have 3c raised to the 5th. So we're looking at property number 6 here, where you have AB to the m equals A to the m, B to the m. This translates to 3 to the 5, C to the 5. If we work out 3 to the 5th, it gives us 243, C to the 5th. Again, if the answer is 4 digits or fewer, write it. This is why the property works, and you don't have to write this down, but when you list out 3C 5 times, you end up with 3 to the 5th, C to the 5th, which translates again to 243, C to the 5th.
And guys, that's the reason that we actually use the properties, because the work up here is much more simple than writing out all of those 3's and all of the C's. So that's the main reason for these properties, is so that we don't have to write out all the 3's and all the C's. It's a kind of a shortcut for how to figure those out. All right, number 7 says n to the 3rd raised to the 4th times n to the negative 2 raised to the negative 3. Okay. This time we're going to be using more than one of these properties, but the first one that we're going to use is we're going to take care of the power raised to a power. So the n to the 3rd raised to the 4th and the n to the negative 2 raised to the negative 3. Again, anytime you have a power raised to a different power, you're going to multiply. So that's n to the 3 times 4 and n to the negative 2 times negative 3, which is going to give us n to the 12 and n to the 6. And so now I can actually turn around and use property number 4, which says if I have the same base and I'm multiplying, I can add those exponents. So here I have the same base. There's an n here and an n here, so that's the same base. So I can take those exponents and then add them. So n to the 12 plus 6 gives me n to the 18.
Make sure that you have that down before you move on. All right. Number 8, we're going to be looking at 2 properties here again. We have j to the 6 times k to the 3 raised to the 2nd power. So the first thing we're going to do is choose our first property, which is going to be property number 6. We have more than one base inside that parentheses, and we have an exponent outside of that parentheses. So that exponent is going to apply to everything inside the parentheses. So we have j to the 6 raised to the 2, k to the 3 raised to the 2. So you need to rewrite the problem like this and go ahead and work out this first step before we look at the second one. Now we're going to choose another property. When we have a power raised to a power, we apply property number 5. That equals j to the 6 times 2 and k to the 3 times 2. We multiply that out, which gives us j to the 12, k to the 6. Go ahead and get that down in the work before you move forward.
All right, number 9 says 3 to the 2nd raised to the 4th and 3 to the 3rd raised to the 2nd. So the first thing I see here is that I have a power raised to a power. So I'm going to take care of that first. And I'm going to say 3 to the 2 times 4 and then 3 to the 3 times 2, which gives me 3 to the 8th and 3 to the 6th. Now I'm not finished because the 3's have the same base, so I can turn around and use property number 4 as well, which says if I have the same base and I'm multiplying, I can add those exponents. So this becomes 3 to the 8 plus 6 power, which is 3 to the 14th power. Take a minute, make sure you have this written down before you move on.
All right, look at number 10. You have 2 to the 3 times w to the 5th raised to the 4th. Get that down. And then let's look at which property we're going to use first. First property we're going to look at is going to be number 6. When I have something inside the parentheses raised to a power outside the parentheses, then that applies to everything inside. So my 2 to the 3rd is raised to the 4th, and my w to the 5th is raised to the 4th. Property number 5 tells me that when I have a power raised to a power, I multiply my exponents. So that becomes 2 to the 3 times 4, w to the 5 times 4, which equals 2 to the 12 times w to the 20. I can simplify that out further by saying 4,096 times w to the 20th. Get that down before you move on.
All right, so now we should be able to use multiplication properties of exponents to evaluate and simplify expressions. Again, don't forget to bring your worksheet and your notes tomorrow to class. Thank you for watching.